So the types of error we talked about, like if you were a medic on a battlefield somewhere, does that sound familiar?
Yes.
Yes, okay. Should have led with that. Okay, understood. So let's take one that's a little more mathy, the kind you'll actually see in the homework. But first off, does anyone remember, or can find it very quickly in their notes, type 1 error? What is that reference? Yeah, all right. You're very excited over there. What's up? What is it?
Reject a true null hypothesis, right?
All right. Reject a true null hypothesis. I like it. And the way I remember it is type 1 is a shorter phrase. Reject a true. Somebody else know what type 2 error was? So either the null is true and we think it's not. What's another way there could be an error? The null is false, but we think it's true. So we fail. So type 2 would be fail to reject a false hope. Oh, yes. Beware the false hope. Okay. All right. I like it. So last time I did an example that was less mathy because I think that kind of helps us. Then you start to see if one of the errors is worse to make, then you can kind of set your alpha. I think I did tell you, let me see if anybody remembers this, and maybe this is a way to make sure I told you this. I'm pretty sure I told you what alpha actually means in terms of the errors. Does anyone remember that? You're like, dude, you're pushing it, man. Shit, this thing I want to shoot. So alpha, let's see, watch this. What if the null hypothesis is true? Don't put that there. So the null is true. But we reject it. We think it's false. What would have happened that would have led us to reject it? What would have happened in our test? What would we have done? When do we reject the null? What has to happen? We have to, several ways you can answer this question. Where do I have to get in order to reject a null hypothesis? Very appropriately named. Rejection region, right? So let's say in this case it's up here. And let's say, so what is the area in this tail? I'm not looking for a number, I'm looking for just a variable. You guys all know this. If I know it's a one-tail test, right? And I tell you it's a z-score, what else do you need to know from me to look it up on the t-score chart? What else do you need to know? It's a one-tail test. It's a z-score. No. Confidence intervals always make how many tails? 2. I still would have to know what. What's the area in the tails? What variable do we give that? Greek letter A, the symbol has a tail, it's almost too good to believe. Alpha, I love it. So what is the area in the rejection region? It is always alpha. So everybody sort of with me? All right. Okay. So, what's the probability that I get a sample here if that really is the real mean? I don't know if the fact that I haven't given you a number, but who gives a shit? What's the probability I get a sample here? Well, how many samples are here? What percentage of samples do show up here if that's the real mean? I didn't give you a number, but who cares? What percentage of samples are in here? I can read, you guys are awesome because I don't have to take a lip reading class. I just get practice with you guys all the time. Don't get me wrong. Please continue doing that if that's how you feel comfortable, because at least that's some kind of answer. Alpha, right? Alpha's in there. That's the whole idea. Alpha is the area in the freaking tail or tails. How does that relate to probability? It exactly equals. We know that in a visual of a probability distribution, If the whole thing is 1, the area equals the probability. So let me say this again. If this is really where the mean is, what is the likelihood that we get a sample in here? Alpha. If I get a sample in here and that is the real mean, we have made this kind of error. Do you see? If I get a sample in there, what is my conclusion? What can we do with the null? We can reject it. But what if the null actually is true? We made a type 1 error, correct? So if a type 1 error means everybody dies or something really bad, right? That should hopefully be everybody's kind of like really bad, but whatever's worse than that for you. If it's a really bad outcome, don't we want to make alpha smaller or bigger, right? If it's really bad to make this kind of error, then I want to make alpha smaller. Does that make sense? If it's really bad to make this kind of error, and that is the probability of making that kind of error, I could just make alpha smaller. Does that make sense? Okay, maybe. Okay.
So do we want to make alpha smaller?
If this happening, if this kind of error, if I make it and it's really bad, or at least worse than a type 2 would be, right? If the situation, and last time we talked about a very specific one, the medic. They either think the person's alive when they're really dead, so they waste time, or they think they're dead when they're really alive, so they don't even try to help them. So if you can figure out which one of those is worse, right? If this one is the worst one, I want to make alpha smaller, so it's less likely I make this error. Does that make sense? Alpha is the probability that I make this kind of error. So all I'm doing right now is trying to show you why would alpha change. Every problem we've done, alpha's been different just about, right? Sometimes it's 0.05, sometimes it's 0.1, blah, blah, blah. You with me? Are you with me? All right. Why this shit is that? Well, because how bad is this damn error to make? Doesn't make any sense. So we can control the probability of making one of these errors. We cannot control it and make it 0%. We can't. The only way to make it 0% would make this impossible to pass. It would be no reason to do the test because it would always, we would always fail to reject. It would be no good. Okay, maybe. All right. Okay. So in terms of the homework's not going to ask you any of that. That's just the behind the scenes. Why do we have different values for alpha? What the shit does it mean? And what does it actually come from? So if one way to look at it, it's the probability of making this kind of error. Okay. Maybe. So for example, real quick, if the null was, so we're at a nuclear plant. I like going to a nuclear plant on these. The null is all is fine with the reactors. What would the alternate be? Something's wrong. All right. And if you think about it, wouldn't you have a lot of gauges, a lot of instruments, kind of like keeping tabs on all the coolant temperature and the state of the thing and if there's any seismic activity? Don't you have a bunch of freaking sensors? And what are they trying to do? They're trying to collect data to show evidence that it's not good, that there's something wrong. Does that make sense? That's why you have all these damn sensors going. You're trying to find evidence that something's wrong. What would a type 1 error mean? What's the reality? In a type 1, what's true? Go ahead.
That you think something's wrong and it's not?
Yeah, the reality is that the reactor's fine, but we think it isn't because we reject this. Are you guys with me? Type 1, it's always good to start with what's the reality. In a type 1 error, this is true, so all is actually fine, but we think it isn't. All right, what's a type 2 error?
Something's wrong.
Something is actually wrong, because in a type 2 error, the null is false. That's false. So something is actually wrong, but we think what? It's fine. Now, this has got a very, very, very easy answer. Which one of those is worse? Hopefully it has an easy answer, unless anybody out there is like, humanity's had enough time, I think. It's time to bring on Godzilla. So which one's worse? Type 1 or type 2? Which one's worse? I thought this was straightforward. Type 2 is freaking bad as shit. Type 1, we go in there, we analyze it, but everything's fine. So, oh well, that's much better than, I think everything's like, oh, what the shit was that? That's bad. It's bad, okay? All right, maybe. So, if this one's worse, and this one's not that bad, would we want alpha to be small or big? That's a beautiful question. Alpha is the probability of making a type 1 error. We just said type 1 is a much better than type 2. Correct? You want it to be bigger, right? You'd rather make this error. And it should kind of make sense. There's more to this story. It isn't perfect, but the smaller alpha is, the bigger this guy's probability is. The smaller this guy's probability is, the bigger alpha is. Does that make sense? So I want this error to be small, correct? I don't want this to be happening. Do you guys agree with me? Which means I'd rather have this error bigger, so I can make alpha big. I really want this to, so here's normal functioning in here, right? I am going to get off my ass the minute that starts to go towards the yellow. I imagine this dial, very simplified. I'm sure they have something like this, but maybe it's digital. I don't care. It's like a lot of green, and then it's got a little yellow, and then it's got this blood red, right? Blood red means, hope you have your affairs in order, right? So the minute that dial starts to go towards the yellow, I'm not waiting for the damn thing to go in the yellow, am I? So I'm not gonna put my tail where, I'm gonna put my freaking tail there. Shit, yeah. Does that make sense? If you make alpha big, that means it's more likely to make this error, and it's therefore less likely to make this error. Do you guys see that? Because what happens if I get in here? If I get in here, I'm gonna reject this, I'm gonna go check on it. It's much better to go check on it more often than less often. Does that make sense? Okay. So there are some problems in the homework that are more English, right? Are you with me? So that we've done a few examples like that. Any questions on this? It's always funny, I see so many faces that basically look like this. And nobody says anything, so I just have to keep going. I know there's a question in there, but what can I do? I haven't developed my ability to read minds yet. Okay. So what about a more mathy one? What if the null hypothesis was the percentage is less than or equal to 11%? So what would the alternate be? Greater than 11%, right? We haven't done percentage ones yet, have we? Okay. Yeah, I'm a good teacher. Sorry, I felt like we had already done it. We'll do some examples, obviously, like that in a minute. What would a type 1 error mean? So this is a lot less wordy. Sorry? Don't know. Yeah. So what would a type 1 error mean? This is all they tell me. This is all I know. What would a type 1 error mean? What's true for a type 1 error? What's true or what's false or what? What's the type 1 error? Reject a true null, correct? So in reality, so here's exactly how I'd say it. Reject a true null. So in reality, the percentage is less than or equal to, or you can say at most 11%, but we think it's greater. Yeah. Do you guys see what I'm saying? A lot less interesting, but oh well. So there will be some problems in the homework that are more just pure numbers, and that's you treat it the exact same way. It's just a little less interesting than, nuclear annihilation, obviously. Do you want to play a game? All right. Is that you guys doing okay? So you will see some problems with types of error.
I have an appointment here.
Oh, you gotta go. Okay.
Is there any handout or something?
Just this. Yeah, just the practice test. You already got it,
Oh,
right?
yeah, I got
Yeah.
it.
Whatever your stuff is here. Okay.
Thank you.
All right, so let's do this. Let's do an example. Let's see what happens with a percent problem. There's going to be a few changes, which kind of makes sense. I'm still going to have the same 5 steps. But you guys help me. If I have a test about a mean, how can I tell if the distribution is going to be normal enough? Either it says it is or n's greater than 30. What about percentages? What has to happen for a percentage distribution to be normally distributed? Somebody started, I think. Yes. So for confidence intervals, we don't know P. So therefore we have to use P hat and Q hat, right? Okay. So step 2 is going to change because now you're not going to be able to say n greater than 30. You're going to have to check NP and NQ. Also, step frickin' 4 is going to change because we currently don't have a z-score formula for P shit, do we? Very interesting sentence I just put together. We have a z-score formula for x bar minus the mu, blah, 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 right? But we have not yet developed a z-score formula for percentages. And you're all like, dude, formulas all over the damn, I don't know what the hell we've done. All right. So normally, step 4, so this is step 2 in the hypothesis test step. Step 4 is normally where we do this kind of thing, right? Or we do this kind of thing, right? We've seen both of those, correct? Could be a t-score thing or a z-score thing. That's what we did last time with that one handout I gave you guys. We did, if I remember correctly, there was a z-score example and a t-score example. This is not going to work for us. We're not going to have frickin' means. We're going to have p hat. So we have to develop a z-score formula. So let's do that right now. What will the z-score formula look like for percentages? First off, can somebody tell me what I'll get it started, the confidence interval formula was for percentages? Do you guys remember? Plus or minus z. Beautiful, right? Also, just to put it up here for comparison, what must this represent then? No, I didn't. The error would be z times, well, that's the error. What's that part I circled? Compare it. What must it represent? I couldn't read that, sorry. My lip reading is not that good yet. Somebody just said to me, that would be the, what's this? What's that? What's this? What's this? I love it. You're all like, keep asking, man. Anything's going to happen. That's the standard deviation for groups, correct? For means. This must be the standard deviation for percentage from a group. That's what that must be. Okay. So watch. For percentages, z star is x, but like I put over here. blah, 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 right? It's going to be our sample stuff minus the supposed reality, the supposed population thing, divided by the correct spread. Right. Right? And this, of course, is this. Is everybody with me? Is everybody with me? Because that's what sigma sub x bar is. It's sigma divided by square root of n. Okay. So what's the z star formula going to be for p stuff now? It's going to be our sample percentage, which of course is what symbol for sample percentage? Yeah? P hat. I love it. You're like, keep going, man, sounds like. Right. So p hat minus p, so our sample percentage minus what we're assuming to be the population percentage, divided by the appropriate spread. And what did we just say that was? Right? This thing. And here's the difference. In this case, we're going to know what p is, so we don't have to use any hatted ones. Still think it's a pretty good band-aid. The hatted ones. All right, so let's do this. Let's do a hypothesis problem. The nice thing is, it's all the same 5 steps. You still have to identify the claim, the hypotheses, then you have to tell me if this is normal, what do we use, blah, blah, blah. It's all the same 5 steps. Just the formula for this is different, of course. It's got to have P stuff in it. And then how I check to see if it's normal is different because it's got to reference the percentage. Right? So let's try this. Okay. Let's see. We talk to, well, let's see. We feel the percentage of people who take online classes, sure, when has increased. It was 31%. We talked to, you could do it, Jeff, 217 students, and find, what do you find, Jeff? I don't freaking know. Let's say 70, you got it, buddy. 74 take online classes. Okay. All right. That should make a lot of sense, correct? I mean, this is the reality. There's a lot more online classes because now everybody's a little more comfortable with online classes since we all had to frickin' do it. No other choice. Some of us, I see a lot of you guys agree with me, I never want to do it again. It eats away at my soul on the little black boxes with names. It just takes away a little more of my sanity. So no thank you. Okay. First question is, what's the claim that's being made? Just tell me in English, what's the claim being made?
Online classes increase.
Yeah, online classes have increased. Good. So that's the claim. We feel percentage of people who take online classes has increased. Great. What was it before?
30%.
So what is the claim in Mathish?
Greater than 31.
Be more specific. What's greater than? Yeah.
Percentage of
P greater than 0.31. Always immediately change your percentages to real numbers, right? Numbers we made up, percentages we like doubly made up. So make them into real numbers. Okay. Do a little dance. What one is that one? Is that the ho or the ha? Which one is that? The null or the alternate? Why? Doesn't have an equal sign. You gotta love that shit. We kind of set it up so that this guy's got the thing I cannot show evidence for, and this guy does. That's how we set it up. So that's going to go here. So what's the null going to be? Less than or equal to? Kick ass. So how many tail tests will it be? 4? Sorry?
1.
1. Yeah, it sounded like 4. That was really nifty. I kind of like that. It's like, dude, you got to do this in like 5 dimensions. Okay. So 1 tail test. I'm very sorry. It sounded like you said, which really was neat. You guys all with me? I mean, there's not much different here. Just be really careful. I notice a few of you guys, when you make it a confidence interval for a percentage, you say the word mean, which makes no sense. It's a percentage. Does that, you see what I'm saying? So if this is a hypothesis test about percentages, use P, right? That'll also remind you which formula you're supposed to use. So obviously this dude is going to be on our formula sheet, right? Okay. So what do I have to check to see if we're allowed to do anything? Poor little purple. You're just not going to cut it. How are you doing, blue? Okay. What do I have to check to make sure? What do I have to check? What do I want to, before I can do something? Is it normal? So what do I have to check to see if it's normal? So I always have to check to see if it's normal, right? So in this case, what do I have to check? No. What's greater than or equal to 5? So now I'm going to check NP. I'm not going to check NP hat for 2 reasons. I don't know what the shit P hat is yet. And I wouldn't know at this stage of the game because I haven't taken a sample yet. But what do we always do in a hypothesis test? We assume this number is true. So we're going to assume P is 0.381. So we know that shit. The only time I ever want to use sample information is if I don't know the population information. And we assume we do. There, we know it's 0.31. Nah. So I really want you to understand that feels a little bit like cheating, but all it is saying is, assuming this is true, we're going to try to show a contradiction. Assuming you're right, look what just happened. So you must be wrong. That's what that's the basic setup of a hypothesis test. How you guys doing? Still the same check. I'm just not going to use P hat. I'm going to use P because we know what it is. So remind me, which one do you use if you have both? Sigma or S? You got both of them. Which one do you use? I'm going to use frickin' sigma because what's S purpose? To be an approximation for sigma. So if I have it, so what's P hat's purpose? To approximate P. So if I got P, screw it. I'm not going to use P hat. Okay, maybe. Okay, I can see a lot of enjoyment on your faces. You can pretend like that's what it is. Okay. So help me out. What is N? What is N? And what's P? We're assuming P to be 0.31. So help me out. What's Q going to be?
8 is, wait, I don't know.
0.669.
All right, so these have to add to be 1, right? Okay. So can you do that real quick for me? What is that? 67 point something maybe. 67.27. And then this one you're gonna get 149.73. You said it right, Jeff. And those are both at least 5. Is everybody with me? You guys with me? Those are both at least 5. All right. What does that mean? It's normal enough. 11. What if either one of those was not at least 5? And then what could we do? I like it. What else? What? Anybody else? What could we do then if one of those or both were not greater than or equal to 5? They were both 3 and 4. What could we do? So somebody's got the answer back there. I'm going to translate. You're not saying this. She's saying you can't do shit, Jeff. Can't do shit. If it's not normal, I can't do shit, at least in stats 1. We know this, correct? So first thing I check for a means problem, I check to see if it's normal. Is it normal enough? Either says it is or n's greater than 30, right? Remember for percentages, how many confidence interval formulas were there for percentages? How many confidence intervals total formulas did we learn? You could do it. X bar plus or minus Z shit, X bar plus or minus T shit, and then P hat plus or minus Z shit. That's it. Do you remember I told you T-scores were invented for means? With percentage problems, it kind of kicks ass. Either it's normal, and I can use a Z-score, or it ain't, and I can't do shit. You guys sort of with me? Kind of, sort of. All right, so in this case, I can do something, which means I can use Z-scores. If either one of those was less than 5, in reality, what I would do is I would just take bigger and bigger samples until it got above 5. Does that make sense? So there's a problem in the homework that's exactly what I just said. So if you were paying attention, I just gave you the answer. And if you weren't, too damn bad. What's the next step? Now that we know we're allowed to use Z-scores, what's the next step? And it's fine to use notes or whatever. Yes, rejection region. So what have I not told you yet that we need to know? Alpha. How many tail tests is it? One tail. So it's one tail. I'll tell you right now, we'll use alpha equal to what, Jeff? I don't know, man. 0.1. Well, that's really pathetic. Make it 0.05. I don't want to be that pathetic. Poor little problem, doing what it can. So make alpha 0.05. Take a minute, I'll wait. Look up the right score.
Why is it up to 1
Because I want it to be. And sorry. So real quick. In the real world, when you learn enough about your own field, you'll have an internalized sense of what alpha should be. In the real world, there is no alpha, right? There is no truth. You with me? I don't know. In this not real world yet situation, they're going to give us alpha, so we don't have a way to know what alpha should be. The most commonly used alpha is 0.05. So if the book doesn't tell you, you assume it's 0.05. I think in a few problems they don't tell you. Does anyone think they've got the Z-score for this? One tail, 0.05. All right. 1.645. Is anyone else getting that or no? Yes. Okay, good. Because that's the right thing. Where will our tail be? Yeah, 1.645. So if Z star is what? If Z star is what, then we can do what? I love that question. Z star is purple, then we can go home. No, it's not. Z star is, how do I get in here? That's the rejection read, right? How do I get in there? The Z star is greater than 1.645. What can we do? We got to the region that is called rejection. So what can we do if we make it in there? Reject the. Oh, I like look in your face when you said. Hopefully it's all right. I'm funny. If I offend you, then wait a minute. I'll do it again. So if Z star is greater than 1.645, we reject the null hypothesis or the. Oh. What does that mean I can do about the HA? Support. Kick ass. If the one guy looks like he's wrong, the other guy looks like he's right. So again, doesn't this, and I know, well, we've done a decent amount of these hypothesis tests together. You should be at the point where you're like, this feels just like hypothesis test. The only difference was we used the letter P there. We had to do the correct check, right? This step is exactly the same. And the next step is going to be different. Because we have to use the correct formula to get our Z star, right? Got no room anywhere. Arg. I'll write really big. So what's the formula I want to use? It's going to be our data minus the supposed middle divided by this standard deviation we borrowed from confidence intervals. And again, this formula is just going to be sitting on your formula sheet. So from a student perspective, I've got a hypothesis test staring at me on a test. It says test the claim about the percentage. I'm like, oh, so I want formulas with P's and Q's in them, correct? So I need a Z-star formula. This is the only one that's got P's in them, so that's the one I'm going to use. Do you guys see what I'm saying? I don't want to ever teach that way, but now that you've suffered through all of my derivation of shit, that's the way you can look at it. Okay, maybe. All right. Have we figured out what P hat is yet? Can you guys do that for me? How do you get what P hat is? Yeah, what do we see in our sample? We saw 74 out of 217. All right, let's see if Jeff made a P hat that actually makes sense here. Oh, shit. I don't know. I don't know what past Jeff did now. These make sense. I try to make it about 0.33 or something. 0.341? All right, good. Yay. Do I need Q hat? Look at the formula. Do I need Q hat? Nope, screw it. Don't need Q hat. Screw him. I got the P, I got the Q. All I need is our sample data, and the rest is based on the population, which only makes sense because we're going to use the population data when I have it. Okay. So this will be our data minus the supposed middle divided by all this mess, which makes it really neat to put it into the calculator. What was it, 217? I don't know if you guys can see that over there. I don't like these long rooms. If you can see it, we're all good. Okay. All right, I'll wait. You guys plug it in a calculator. I'll do it too. Let's see what we get. The one thing you got to be really careful about, I did it for you here. You want the top in parentheses. And at the bottom, you want to make sure you don't come out of your square root until you get all that stuff in there. All right. That makes sense, Jeff. It's okay. Sorry, I'm trying to console myself. It's still a valid test. I just wanted to make it a little more interesting, but oh well, too bad for me. Does anyone think they have what that Z-star is? People will look at me like, I got a number, dude, but... Anybody? I got something less than 1. Okay, does that make anybody feel more confident to say it? What'd you get? Why always 2? Because their Z-score chart just goes up to 2, right? 9. All right. No. Everybody's like, yeah. All right. So, right there, can we tell what the answer is to this hypothesis test? Did we make it? Did we make it? No, right? We're well short of that, right? Here's 0.99. So we already know the answer. What's the answer? Do we reject the null or fail to reject the null? Fail. Of course we do, because we didn't make it in the region that's called the rejection region, right? It's almost too nice the way it's said. So if we don't make it in there, we fail to reject the null.
So is failing a good thing then?
It really depends on which one of these is our claim, right? The claim could have been this, in which case we're hoping we fail to reject it. Does that make sense? If your claim is the null, you're like, oh, I really hope it don't reject it. In science, though, it doesn't matter. If we're like, that's our number, like, we're excited either way. We're like, we just disproved this. Holy shit, that's amazing. You know, we love that shit. But yeah, so our claim is this. So we were kind of hoping to reject this guy, and we didn't. Right? So we fail to do these things. We fail to reject the null, and we fail to support the ha. Now, just to be nice to the other side of the room, I'm going to put the conclusion here. There you go, Jeff. Which one of those two am I going to build my conclusion off of? What was the claim? Which one? Here's the claim. Which one was it? The ha, correct? There's the claim. There it is, the ha.
Yeah.
So then I want to use this language. Fail becomes we. Did we find evidence? Did we make it? Nope, we failed. So we have not found sufficient evidence to do what? Support the claim that plagiarized. The percentage of people who took online classes has increased. The percentage of people who take online classes has increased. I mean, just copy it down, correct? Which is fine. This is one place in real life it's fine to plagiarize because your conclusion has to reference what the claim was. You want to tell somebody, hey, this is what happened to your claim. Otherwise, do not plagiarize. ChatGPT is writing this. Oh man, it'll write a whole paper. Oh man, come on. It'll do freaking math problems. It'll do them wrong sometimes, which is hilarious to me. Anyway, sorry. If you don't know ChatGPT, what the shit? It's insane. Ask it to create a 6-word horror story. It's amazing. Sorry. If you haven't played with that thing, I'm sorry. This is exactly all the same steps. You guys agree? They're exactly the same steps. There were just a couple that were different because talking about percentages, got to use the right check, got to use the formula that's actually got percentages in it. All right, so here's where you guys get to do this. All right, so let me make up a problem for you. I'm going to put it here, but I'm going to leave all this other shit up here. The percentage of, now let's do percentage of houses gave out candy has been 41%. We feel that it is the same now. Okay. Sample 387 households. We find, oh shit, what do we find? What do we find, John? Let's say 151 gave out candy. Test the claim using alpha equal to 0.01. Okay. Can you guys all read that? Make sure the people at home can. Catch up to you guys. So what's the claim? Equal 0.41, so where does that go? That's so desperately has the equal sign in it, right? That's really so. So what's the opposite of equal to? Not equal to. Real quick, back in the day we used to use this symbol, which actually in a way makes more sense. Because it actually very directly tells you it's a two-tailed test. But math people, we don't like multiple symbols in a row when we don't need it, so we just changed it to this. So it's totally a two-tailed test, totally. What do you call it, alliteration? Is that alliteration? Totally a two-tailed test. Good? Sorry. What's N? 387, what's P? 0.41. So what is that business? Hundred and something. 158.67. So the 387 times 0.59, right? That's the Q. That's going to be what, Jeff? That's going to be 228.33. And the big thing that's important is these are both bigger than or equal to 5. Which means what? Normal enough. We can do something. We do z-squares. Okay. So two-tail, bam, bam. 0.01 alpha, two-tail test, first column on the t-score chart, go all the way to the bottom for z-score. What do you get? 2576. I like what somebody, if you do it a different way, you're going to get 2575 from the z-score chart, so I can accept either one. Because they're both numbers that work depending on which thing you look at. So I'm just going to put down this one. So how do we get to the rejection region if Z star is you got two ways to do it, right? Z star is greater than positive 2576, or it's less than negative 2576. We can reject the hope, support the hop. All right, let me stop for a minute. Let everybody at home see what's going on. So again, just to remind you guys, the null is the one who thinks it should be in here, right? Therefore, if we get outside of there, it only makes sense that it looks like this guy's wrong, because he thinks it should have showed up in there, correct? Most samples should show up in here if that's the real mean, or in this case, the real percentage. If I get something really far off from that, it's more likely that's not the real center, right? Does that make sense? No? Okay, shoot. All right. Now, part D, we're ready for this sucker. What's P hat? How do I calculate that? How do I calculate it? 151 out of 387, and you get, if I remember correctly, 0.39, is that right? Yeah. 3901. Remember, you have to round these to at least 3 places, so 39 is fine, 390. And then you just plug that shit in, right? So we get Z star is 0.39 minus what? 0.41, that's the supposed middle, divided by square root of 0.41 times 0.59 divided by 387. Is that what you guys did? Sure is, Jeff. Is that what I did? Yay, look at me go. So what'd you guys get? It's remarkably, almost perfectly something. Did you guys get anything? Yes, basically negative 0.8. Now, real quick on the last problem, I forgot to do this, but let's do this problem. This problem's probably a good one. What's the p-value? So many freaking p's, Jeff. Right? Anyone remember what the p-value is? So let me put this down on the picture. Here's 0.8, negative 0.8, plop. The p-value is related to the area. Can you guys tell me what the area in this tail is of the z-score that we found? What's the area in that tail? So look up negative 0.8 on the old z-score chart, like back in the olden times, a few weeks back. What do you guys get? Sorry?
4681.
4681? 4681? Nobody wants to say. Is that what you guys got? Okay, somebody's telling me. 4681. Does anyone remember that's not the p value? Is that what it is? I don't know. Should I look at it?
Yeah.
2119? All right. Did you look up 0.08?
Mm-hmm.
Oh, okay. Yeah, that makes sense. So 0.2119. Why is that not the p-value? Do you guys normally that would be the p-value if this was a one-tailed test. It's two-tailed, so what do I do to this? Double it, right? So the p-value in this case would be 0.4238. I don't know if you guys remember, but when is the p-value more evidence? What values could the p-value take on to represent more evidence? Do you guys remember? If the p-value is blank, then that's more evidence that there's a real something happening. Do you not remember at all? Oh shit, all right. The smaller the p-value is, the more evidence that is, that it isn't just random fluctuations. That is a freaking huge p-value. What that represents is about a 42% chance that we would get the sample that we did, if that's the right middle, if this is the right middle. So that makes sense then that the result is we fail to reject. Right? So that's a pretty high probability that that's the right middle, so we're going to fail to reject the damn thing. The smaller the p-value is, the less likely that that's the real middle. The more likely is that we can reject that statement. So we fail to reject, and we fail to reject the null, and we fail to support the alternate. So in this case, what was our claim? Which one was our claim? HO or HA? HO, right? Here's the claim. Here, that's right there. So it's the HO. So what language am I looking for? Which one? First one, right? Because I mean, I really want you guys. When I get students who kind of start to understand the steps and how to do them, the biggest thing that's still left over is how the shit do I word my conclusion, right? Which is understandable. Conclusion is always the worst part because it's the part where you actually have to figure out what the hell the numbers mean. The beautiful thing about this is you can always immediately write down these two statements. You just can't, based on what you get here. Then you just go, okay, the claim was the null, so I don't want to use that language, I want to use this language. So once again, we failed. We have not found sufficient evidence. Whoops, it's become EV. To what? Reject the claim that What? Reject that what? Yes. Stay the same. I love it. Several ways you can word this. To reject a claim that the percentage of houses that give out candy has stayed the same, or is still 41%, or whatever you want to say. Real quick, what was our claim again? It was the no, correct? Are we happy or sad about the results? If our claim is the null and we failed to reject the null, are we happy or sad about that? Happy. Our claim is a null. I don't want to reject the poor little dude, especially if it's like, oh, I feel really good about this claim. You don't want to reject it then. But again, scientists, we don't give a shit. We're like, holy shit, really? What I thought was real is not real? That's the most exciting thing. All right, so I'll tell you this. Oh, what time it is? You guys are so spoiled. We're supposed to go till 2:35. You guys are all packing up. I will say this. I'm going to make section 10.2 worth more. No, I'm going to make it extra credit. That's what it was. I'm going to make section 10.2 extra credit. I'll talk about it a little bit on Wednesday. So Wednesday's review day. Everybody got a practice test, correct? So I'll have the quizzes graded by Wednesday. I'll have the answer key for the practice test Wednesday. Test is next Monday, of course. 10.2 is extra credit. So if you don't do it, you're fine. If you want to try it, great. I'll have a bonus question from 10.2 to give people credit if we want to try that bonus out. Otherwise, we're golden. So go ahead and pack up. You're good. You can go. I just like to mess with you. Don't forget your stuff, please, dear God.